Chapter 10 is going to be set up into two different sections. The first one is going to deal all with triangles. So we're going to deal with triangles this week. So hopefully today, section 1 is a little bit of review because basically today is just SOHCAHTOA. So SOHCAHTOA on your paper, if you don't remember what each one stands for, sine, which is the SO part, stands for opposite over hypotenuse. That's where the O and the H come from. Cosine, ca, is A and H, which stands for the adjacent side and the hypotenuse. Tangent, TOA, stands for the opposite side over the adjacent side. So go ahead and pause this if you need a second to write that down. Otherwise, we'll just move on. So here are some of our examples. The key idea to remember here is that you're always starting at the angle. So in example A, it wants me to find the sine of B. So I'm going to go over to angle B, and I know that sine is so that means I need O over H. So the opposite from my angle B, opposite would kind of be across. So my opposite side is 4. So that's going to give me 4 over, and then your hypotenuse is always the side across from your 90, okay? So across from the 90 is 5, so the sine of B is 4 over 5. The tangent of B, TOA, is opposite over adjacent. So we already said that opposite our angle, again, always start at the angle that you're looking at. Opposite from there is side with the 4, and the adjacent, okay, I kind of, sometimes it gets confusing. So adjacent is the one that's literally attached to my side B, so that's going to be my 3. So the ratio here is 4 over 3. Okay, you should not divide these out. You should leave them as fractions because all of these are ratios. Okay, example C says the cosine of C. This time I'm going to look at angle C first. So here I'm starting over here, which changes things. Cosine is ca, which is adjacent over hypotenuse. So adjacent is the attached leg. So this time that is my 4. The hypotenuse always stays as my 5 because that is across from the 90. So my cosine of C is 4 over 5. Tangent is TOA, so that's opposite over adjacent. Okay, again, keep in mind we're starting at angle C. This time across from angle C is my 3. Okay, so it does matter where you are. So be careful there. Across from angle C is 3, and then the adjacent, which is the attached, is 4. Okay, so 3/4. If you notice, the tangents between B and C are flip-flopped. Okay, so be careful there. Always start at the angle that you're given. Okay, so let's try some story problems. Example E, a 20-foot ladder is placed against a wall at an angle of 72 with the ground. How far from the base of the wall is the bottom of the ladder? I'm going to suggest for all of these that you draw a triangle to kind of see what's happening. So 20-foot ladder is placed against the wall. Well, then this would kind of be my wall here. We'll make those bricks. Okay, I'm not an art teacher, so help me out here. So how far from the base of the wall is the bottom of the ladder? Okay, well that means this is what I'm looking for. Ladder would be the part leaning on the wall, so that would be my 20-foot ladder here. And it says 72 degrees with the angle of the ground. So that's going to make this angle down here my 72. So now what I'm going to do is, again, you're always going to start at your angle. So I'm going to say, okay, here's the angle that I'm given. What two sides in relationship to this angle do I have? Well, the x is attached to it, so that gives me my adjacent side. And then the 20 is across from my 90, which makes that my hypotenuse. So I have A and H, which is cosine, okay? So that means I have cosine of my angle, 72, equals my adjacent, which we said is x, and our hypotenuse, which we know is 20. Okay, so it's always going to be cosine of the angle, so the angle always has to go right here, equals, and then your ratio from before. So if we're trying to solve for x, what we do next is just multiply each side by 20. So all you need to do is put into your calculator 20 times the cosine of 72. Okay, that should get you 6.18, and then we'll label that feet. If you did not get this, okay, what I need you to do is I need you to check your mode, okay, on your calculator, and you need to be in degree mode, okay? So make sure you are in degree mode if you did not get that answer. Okay, so we'll move on. Example F, a wheelchair ramp is 18 feet long. A building code in the city specifies that the ramp must form a 5-degree angle with the ground. How far up vertically does the ramp reach? Okay, so 18 feet, well, the ramp would be the diagonal part. The building code specifies that it must form a 5-degree angle with the ground. So there's my 5 degrees. And how far up vertically would that reach? So there's my triangle. Again, you're always going to start at the angle that you're given. So this time I'm going across. So that would be my opposite side. This is across from my 90, so that's going to be my H. So I'm given O and H, so that gives me sine. So I'm going to say sine always of my angle. So sine of 5 equals opposite over hypotenuse, so x over 18. Again, to solve for x, I'm going to multiply by the 18. So in your calculator, you just type in 18 sine of 5, and you should get 1.57 feet. Okay, please make sure that you are getting the right answers here. Okay, and one more. Juanita used an instrument to sight the top of a building and got an angle measure of 62. She is 5 feet tall and stood 35 feet from the building. How tall was the building? Okay, so there's a lot more information here. Well, how tall was the building? Well, I know that this part's my building, and that's what I'm looking for, so I know I can put that X. Juanita used an instrument, so Juanita's probably over here. That's my building. She's got pretty little hair. She is 5 feet tall, which is good to know. She's about my size. She stood 35 feet from the building, so this distance would be 35, and an angle measure of 62. So 62 from Juanita. Okay, so if I'm looking at my triangle, I can solve my triangle, again, starting at the angle that I'm given. So I'm given 62, so then my x is opposite that, and my 35 here is attached to it. So now I have O and A, so that's going to give me tan. So that's going to say tan of my angle, which is 62, equals x over 35. So to solve for x, I can just multiply each side by 35 here, and I'm going to get x equals 65.8. Now that doesn't take into account the fact that she's 5 feet tall, because this building really isn't here just like hanging out in the air. Okay, it's really that plus 5. So to get the real height of the building, I need to add the 5 feet that she is tall to give me a final answer of 70.8 feet. Okay, so write down some questions. I'll be back on Wednesday, and then we can answer those if you have any. Otherwise, here's an optical illusion for you today. So see if you can see an Eskimo, okay, or a Native American.